Hey there. Ready to get swept away by the water cycle? You've given us a treasure trove of resources on this one. Articles, diagrams, the works. We even have a picture here of a lake at sunrise with mist rising off it.
Yeah.
Almost magical, right?
Right?
Yeah,
Let's dive in.
it really is amazing when you think about it. That mist rising from the lake, that's not just water disappearing, it's part of a journey, a cycle that's been going on for billions of years.
Okay, let's unpack that journey. The sources you've shared highlight that the water cycle is more than just rain.
Mhm.
It's this constant movement of water, and it's driven by the sun's energy and gravity.
Exactly. And understanding this cycle, it's key to understanding life on Earth. I mean, where would we be without water?
A very dry and dusty place.
Mm-hmm.
But let's break it down. One of the first things these sources delve into is the concept of phase changes. Solid to liquid, liquid to gas, you get the idea. What's fascinating is they say it's not just temperature at play here, but pressure too.
That's one of the things that makes the water cycle so dynamic. You know how you boil water on the stove? You're adding heat, which increases the water molecules' energy, making them move faster until they transition to a gas steam. But pressure plays a role too.
So even though we don't see it, the air around us is actually exerting pressure on that water.
Exactly. And that pressure influences how easily those molecules can escape from a liquid to become a gas. It's like trying to break free from a crowded room. The more crowded it is, the harder it is to escape. Higher pressure makes it harder for water to evaporate.
So that mist rising off the lake in the picture
Yeah.
is water molecules breaking free of the water's surface and becoming vapor.
Yeah.
But it's not just as simple as getting warmer, right?
Mm.
The air pressure matters too.
Absolutely. And this interplay between temperature and pressure, it's happening constantly in the atmosphere.
And this is where our water cycle key stages slide comes in. We've got evaporation, condensation, precipitation, collection. It's like a water ballet. Can you walk us through these stages?
Sure. Evaporation, as we've been discussing, is that first step. Liquid water transforming into water vapor. This vapor, being lighter than air, rises into the atmosphere. But as it rises, it encounters cooler temperatures. And this is where condensation takes over.
So the thirsty traveler who soaked up all that heat during evaporation starts to cool down and can't hold on to all that moisture anymore.
Exactly. And as the water vapor cools, it condenses back into tiny liquid water droplets. These droplets clump together, forming clouds.
And those clouds lead to the next stage, precipitation, which is where things get a bit more dramatic.
Yeah.
It's not always a gentle rain either, right? We have snow, sleet, even hail.
Yeah.
And speaking of hail, this source specifically calls out a connection to those towering cumulonimbus clouds, the ones that look like something out of a stormy painting.
Cumulonimbus clouds are like the skyscrapers of the cloud world. They have incredibly strong updrafts, powerful winds that toss those tiny water droplets way up high into the freezing parts of the cloud.
So the droplets freeze into ice, fall a bit, maybe pick up more water, freeze again, and you get those layers that make up hailstones.
That makes total sense. Okay, so we've got water falling back to Earth in all its various forms. That brings us to the final stage on our slide. Collection.
Collection is where gravity takes center stage. The water that falls is precipitation, whether it's rain, snow, or hail. Has to go somewhere, right? Some of it flows over the land as runoff, finding its way into streams, rivers, and eventually the ocean. But another portion seeps into the ground.
And that's where things go underground.
Yeah.
Literally, because this is where we get into surface water versus groundwater. We've got this great visual here that shows this clear division above the line and below the line.
Exactly. Surface water is the water we easily see and interact with. Lakes, rivers, oceans. Think of it like the water that's readily available to us. But that also means it's more vulnerable to pollution, like runoff from cities or farms.
Whereas groundwater is kind of hiding out beneath the surface.
Right. Groundwater is stored beneath the Earth's surface in underground layers of rock and soil called aquifers. We've got a diagram here labeled Aquifers Explained. And honestly, it reminds me of a giant rocky sponge.
That's a great way to think about it. Aquifers are like these massive underground reservoirs that hold groundwater, slowly filtering and purifying it over time.
So they're like nature's water purifiers.
Exactly. That's why groundwater is generally cleaner than surface water. It's been naturally filtered through layers of earth and rock. But here's the thing. While surface water is easier to access, groundwater tucked away in those aquifers can be more challenging to reach.
Which is where wells come in, right?
Hmm.
That image of a well with the bucket and rope, it seems almost medieval.
It's a technology that's been around for centuries, and for good reason. Wells provide a way to tap into those hidden reserves of groundwater.
It's incredible to think that a well in your backyard could be drawing water that fell as rain decades, even centuries ago.
Huh.
Okay, we've covered a lot of ground here, literally. We've gone from that mist rising off the lake to water hidden deep underground. But now I'm curious about something you mentioned earlier, how pollution affects all of this.
That's where things get a bit more serious. Our actions can have a huge impact on the water cycle, and not always in a good way.
One of the sources uses this powerful image of deforestation to illustrate the point: a once lush forest reduced to barren land. It's a stark reminder of how interconnected everything is.
And it highlights how crucial trees are to the water cycle. They act like giant sponges absorbing rainwater and releasing it slowly, which helps prevent flooding and soil erosion. They also help replenish groundwater. But when forests are cleared, that balance is disrupted.
So instead of soaking into the ground, the rainwater runs off, carrying topsoil and pollutants into rivers and lakes.
Exactly. And this brings us to another major issue: pollution. Think about all the chemicals, sewage, and agricultural runoff that end up in our waterways.
It's like we're accidentally poisoning the very source of life.
And it's not just surface water that's at risk. These pollutants can seep into the ground, contaminating aquifers and making groundwater unsafe.
So even the water hidden underground isn't entirely safe. This is making me rethink that glass of water on my nightstand.
It's definitely a wake-up call. And it's not just pollution that disrupts the water cycle. We also have to consider damming.
Right. We often think of dams as a source of clean energy, which they are. But this source points out they can have a downside, too.
Dams can be beneficial for water storage and hydroelectric power, but they also alter the natural flow of rivers, which can harm fish populations and other wildlife that depend on those ecosystems.
So it's about finding a balance, right? Meeting our needs without throwing the entire water cycle out of whack. And speaking of balance, there's that last question from your research. How does the water cycle influence things like hurricanes and droughts? It seems like those are at opposite ends of the spectrum. It's true, they seem like total opposites, but they're both connected to the water cycle in fascinating ways. Hurricanes, for example, there's like giant engines fueled by warm ocean water.
Exactly. That warm ocean water evaporates on a massive scale, rising into the atmosphere and providing the moisture that fuels those towering thunderstorm clouds.
So the hotter the ocean water, the more fuel for the hurricane. It's kind of scary when you think about it.
It is a bit, especially with climate change causing ocean temperatures to rise, but the connection goes even deeper. Remember how we talked about condensation releasing heat?
Like the thirsty traveler finally getting a drink and feeling a burst of energy.
Precisely. When all that water vapor condenses high in the atmosphere, it releases a tremendous amount of heat, further fueling the hurricane's winds.
Wow. So it's like a double whammy: warm ocean water feeds the hurricane, and then condensation supercharges it.
And then on the flip side, you have droughts, which are essentially a breakdown of the water cycle.
So instead of too much water, you have too little. What's fascinating is that this source says it's not just about a lack of rainfall, it's also about what happens to the sun's energy when there's less moisture around.
Right. Think about it. In a drought with less moisture in the soil and fewer plants, the ground heats up more quickly. And that heat, instead of going into evaporating water, just bakes the ground even more.
It's like turning up the oven instead of putting a pot of water on to boil.
Exactly. And this lack of evaporation means there's less moisture in the air, leading to fewer clouds, less rainfall, and even hotter, drier conditions. It becomes a vicious cycle.
So hurricanes and droughts, two completely different phenomena, both deeply intertwined with the water cycle. What's amazing is that this one natural process has such a huge impact on our planet, from these massive weather events to something as simple as a glass of water.
It really underscores how interconnected everything is. The water cycle doesn't exist in isolation. It influences and is influenced by everything around it: the atmosphere, the land, and even us.
We've seen how deforestation, pollution, even damming, can disrupt this delicate balance. It's a bit humbling, isn't it? But we've also talked about solutions, sustainable practices that can help protect this precious resource.
Absolutely. Being mindful of our water use, supporting reforestation efforts, advocating for responsible water management, these are all things we can do to make a difference.
So as we wrap up this deep dive, it's clear that the water cycle is more than just a science lesson. It's a story that's still being written, and we all have a role to play.
And it's a story worth learning about, understanding, and protecting.
Couldn't agree more. Thanks for joining us on this incredible journey through the water cycle. Until next time.